Hello. So in this presentation, we'll be covering Chapter 5, and actually Chapter 5 and Chapter 6 both cover these categorical statements, which we've seen these before. We saw them a bit in Chapter 1 in particular, but they've been kind of sprinkled in various places throughout the other chapters as well. And so in this chapter, we'll just kind of look at the different kinds of categorical statements themselves and their logical interrelationships with each other. Then in Chapter 6, we'll look at full arguments that are exclusively using categorical statements as the premises and the conclusion of the arguments. So a categorical statement, as we've seen before, is just any statement that relates to classes or categories of things. Another way of describing this is that every categorical statement states a relationship between a subject and a predicate. So here are the four standard examples, the four standard kinds of categorical statements. The subject is just the thing you're talking about, you know, the subject of the sentence. A predicate is some property or attribute, ability, or classification or something like that that you are saying that it stands in some relation to that subject. So for example, in the first one, all S's are P, you're taking this predicate P and you're applying it to all of the S's, right? So all cats are mammals. So are mammals, that's the predicate. Cats in this case is the subject. So all S's are P, all cats are mammals. There are a wide variety of ways of stating a relationship between a subject and a predicate like this, you know, two categories of things. You know, I'm saying that all of them are, you know, all S's are P, no S's are P, some S's are P, some S's are not P, and then all the different variations. But it turns out that no matter what variation on a categorical statement you come across, every single one of them can be converted to one of the standard forms here. And so it's a good idea to go ahead and do that because when we convert these stylistic variants, as they call them, when we convert those into the standard form, it becomes a little easier to recognize the logical relationships between the categorical statements. And then when we get to Chapter 6, it becomes easier to recognize whether the argument that involves these categorical statements is deductively valid or deductively invalid. And so notice that all four of these standard forms of the categorical statements have the same basic pattern to them. They start with a quantifier, as we call it. And so that would be all, no, or some. And by the way, this is going to become relevant later. The all quantifier and the no quantifier, those are called the universal quantifiers because they apply to everything, right? So it's either all, so everything, or no, so nothing. So those are universal, as opposed to the some quantifier, that is called the particular quantifier. So all four of the standard forms of the categorical statements start off with a quantifier, then have the subject, then have the word are, and then comes the predicate. So maybe this is obvious, but here's some simple examples, right? All cats are mammals. No turtles are able to fly, or we might say no turtles are flying things. Some customers are angry. Some apples are not red. And I mentioned stylistic variants, so let's just take a look at a couple of those. They have a whole bunch of them in the book, and it's worth sort of checking those out. But you know, if somebody says only mammals are cats, that actually means all cats are mammals, it turns out. And it's sort of a weird thing to, you know, come up to somebody and say, hey, did you know that only mammals are cats? It's like, well, why are you saying it like that? That sounds weird. Well, you know, imagine that somebody has a reptile and they're like, oh, here's a cat. And you correct them by saying, no, no, sorry, only mammals are cats, right? So only, you know, if it's a cat, it's got to be a mammal, right? So all cats are mammals. Or, you know, somebody might say turtles can't fly. That means no turtles are flyers, are able to fly. There are customers that are angry, so that just means some customers are angry. At least one apple is red, it just means some apples are red. So another thing that we might see, or we're definitely going to see a lot of in this chapter and the next one, are these Venn diagrams. A Venn diagram to represent the categorical statements. So here we have all S's are P, so the circle representing the S's is completely contained within the circle representing the P's. And so all the S's are within the P circle. The opposite, so no S's are P. So the S circle is completely separate from the P circle. Some S's are P, so that means that there's some overlap between the S circle and the P circle. And then some S's are not P, so that means that some of the S's are outside the P circle. Also notice, this is going to become relevant later too, that some S's are P and some S's are not P. It's basically the same Venn diagram. We're just drawing attention to different parts of the diagram. You know, in the some S's are P, we're drawing attention to the place of overlap. Some S's are not P, we're drawing attention to the place where they don't overlap. Okay, so like I said, there's logical relationships between the categorical statements. And so for the rest of the presentation here, that's what we'll look at for most of the rest of the presentation anyway. So first one up, contradictories. So two statements are contradictory if they cannot have the same truth value. So that means that they can't both be true and they can't both be false. So in other words, if one is true, then the other must be false. Or vice versa, if one is false, then the other must be true. Okay, so let's look at, you know, some of these you might just sort of like intuitively grasp that this must be the case. But some of them, it maybe is a little more difficult to keep track of these logical relationships and why they are like they are. So I'll kind of go through some examples here in a little bit more detail. So yeah, they can't have the same truth value. So all S's are P and some S's are not P. Those are contradictories, right? They can't have the same truth value. Same thing with no S's are P and some S's are P. They cannot have the same truth value. They can't both be true and they can't both be false. So if one is true, then the other must be false. Same with vice versa, right? If one is false, then the other must be true. Okay, so let's start off over here. The first one is maybe a little bit obvious, right? If it's true that all S's are P, which is represented by this Venn diagram here we saw, right? All the S's are within the P circle. Then can it also be true that some S's are not P? Well, clearly not, right? If it's true that all the S's are within the P circle, the whole S circle is within the P circle, does that mean that some of the S circle could be outside the P circle? Well, no. So that's pretty clear. So let's fill in a specific example. If it's true that all cats are mammals, can it also be true that some cats are not mammals? No, it's got to be false, right? So if it's true that all cats are mammals, then it's got to be false that some cats are not mammals. By the way, I have all these written down here just because like I said, some of these are sort of straightforward and obvious relationships. Some of them are a little less obvious, a little bit more complicated. And as I'm speaking them out loud, I don't want to misspeak and throw this offline and have to start over or anything. So I wrote them down just to make sure I'm saying it right. Okay, so then if it's false, right, they can't both be false. So if it's false that all S's are P, then it must be true that some S's are not P, right? So if it's false that all mammals are cats, then it must be false that some mammals are not, some mammals are not cats. See, I screwed up. Okay, regrouping, right? So if it's false that all mammals are cats, then it must be true that at least some mammals are not cats, right? So if this is false, this top one is false, then this next one must be true. All right, now let's go the other direction. If it's true that some mammals are not cats, then it must be false that all mammals are cats. On the other hand, if it's false that some cats are not mammals, then it must be true that all cats are mammals. All right, so they can't both be false and they can't both be true. And looking at this one over here, again, the first one might be somewhat obvious. If it's true that no cats are reptiles, then could it be true that some cats are reptiles? Well, no, it's got to be false that some cats are reptiles. On the other hand, if it's false that no mammals are cats, then it must be true that some mammals are cats. Right? So if one is false, then the other one's got to be true. Then going the other direction. So if it's true that some mammals are cats, then it must be false that no mammals are cats. Right? So if this one is true, then this one's got to be false. So then what about when this one is false? If it's false that some cats are reptiles, then it must be true that no cats are reptiles. Okay, moving on to this one. It's a little simpler, contraries, because it's a little simpler because there's only sort of one pair that count as contraries. So these are two statements that cannot both be true, but they can both be false. Or it could be that one is true and one is false. So, if it's true that all S's are P, and again, here we have it represented, all the S's are within the P circle, then it cannot be true also that no S's are P. I mean, these are the exact opposite of each other. And so if one is true, then the other one's got to be false. And that's sort of really obvious by looking at the Venn diagrams here. But they can both be false. So if it's false that, for example, all mammals are cats, then it could also be false that no mammals are cats. Because, as we know, some mammals are cats. So it is false. Indeed, in reality, we know it's false that all mammals are cats. And we also know that it's false that no mammals are cats. So they can both be false. Okay, subcontraries. So again, there's only one pair of categorical statements that count as subcontraries. This is when two statements, they can both be true, but they cannot both be false. And we sort of saw this a little bit before, right? That some S's are P and the some S's are not P. It's basically the same Venn diagram. And so we know that they can both be true just by glancing at the Venn diagrams for the two categorical statements. But, right, so they cannot both be false. So if it is false that some S's are P, then it cannot also be false that some S's are not P, right? At least some of them have got to be P. So let's look at it, fill in an example there. If it's false that some cats are reptiles, then it must be that no cats are reptiles, right? If it's false that some cats are reptiles, then that means the cats category is completely separate from the reptiles category, right? That's what makes it false that some cats are reptiles. So if it's false that some cats are reptiles, then it must be that no cats are reptiles. And if no cats are reptiles, then it must be true that some cats are not reptiles. Going the other direction, right? If it's false that some cats are not mammals, right? So, which seems to be the case, right? Since we know that all cats are mammals, it's definitely false that some of those cats are not mammals. So then that must mean that all cats are mammals. So it must then also be true that some cats are mammals, right? And so they just can't both be false. It just can't be the case. Okay, moving on to the subalternation. And it turns out that the subalternation relationship is the most complicated one because there's the greatest variety of different interconnections, as we'll see. So there's a subalternation relationship between a universal and its corresponding particular. Remember, the universal statements are the ones that contain either all or no as their quantifier, whereas the particular statements are the ones that use some as the quantifier. And so over on the left here, we have the positive versions, right? So all S's are P and some S's are P. We have a subalternation relationship between those two. Over on the right side, we have the negative ones. The negative universally quantified categorical statement, no S's are P. And then the particular negative one. So some S's are not P. So what's the relationship between the universal and its corresponding particular? Well, it's a little complicated, right? So we've got all these different options going on. So let's handle them one at a time. And these are true whether we're talking about the positive versions or the negative versions. If the universal is true, then the particular has got to be true. And this is probably the most obvious one. So if it's really true that all S's are P, then it's got to be true that some S's are P. So if somebody says, hey, some cats are mammals. It's like, well, yeah, I know that because I know that all cats are mammals. So if all cats are mammals, then some cats have to be mammals. Same thing on the other side. If it's true that no S's are P, then it's also got to be true that some S's are not P. So if somebody says, hey, did you know that some cats are not reptiles? It's like, well, yeah, I knew that because I know that no cats are reptiles. And so it's got to be true that some cats are not reptiles. So that one's pretty obvious. It gets a little more complicated once we hit relationship B here. So here, if the universal is false, then the particular is, as they say, undetermined. That is, the particular could be true, or the particular could be false. Let's start over here with the positive ones. If it's false that all S's are P, then it could still be true that some S's are P, or it could be false that all S's are P. So the example here that I'll use are, the subject will be people from Boulder, we call them Boulderites, and the predicate will be, let's say, a particular religious affiliation, let's say Hinduism, because it's a relatively rare, at least in this area of the world, relatively rare religious affiliation. So if it's false that all Boulderites are Hindu, then it could be true that some Boulderites are Hindu. But at the same time, if it's false that all Boulderites are Hindu, then it could be false that some Boulderites are Hindu. That is, there could be no Hindus here at all. Okay, going the other direction. Actually, let's look at the negative ones here for relationship B. Right? If the universal is false, then the particular is undetermined, right? So if it's false, for example, that no Boulderites are Democrats, then it could be true that some Boulderites are not Democrats. But it could also be false that some Boulderites are not Democrats. As you might know, Boulder is a pretty liberal place. It's pretty overwhelmingly, when we're talking about actual party affiliation, it's pretty overwhelmingly Democratic, right? There's not that many Republicans, at least not many registered Republicans in Boulder. And so it is indeed false that no Boulderites are Democrats. But even if it's false that no Boulderites are Democrats, it could be false that some Boulderites are not Democrats, or it could be true that some Boulderites are not Democrats. All right, so moving on to relationship C here. If the particular is true, then its associated universal is undetermined, right? It could be true or it could be false. So, for example, let's say some S's are P. Let's say that that's true. So for example, some Boulderites are Republicans. It's like, okay, that's true, right? That is a true thing. There's not a lot of them, but some Boulderites are indeed Republicans. So that, what does that tell us about the associated universal statement? Well, it could be true if, I lost my place. Yeah, there we go. It could be true that even though, yeah, so if it's true that some Boulderites are Democrats, right? If this is true, then the universal could be true or false. So if it's true that some Boulderites are Democrats, then it could also be true that all Boulderites are Democrats. Or it could be false that all Boulderites are Democrats. Then let's look over here. If the particular is true on the negative side, then the universal could be true, or it could be false. And the Boulderites as Republicans one works here. So if it's true that some Boulderites are not Republicans, then it could be true that no Boulderites are Republicans. Or it could be false that no Boulderites are Republicans, right? There could be some. Okay, now let's look at the relationship D here. If the particular is false, then its associated universal must also be false. So if it's false that some cats are reptiles, for example, then it must also be false that all cats are reptiles. Right? So this says it's false that some S's are P, then that means that there's no overlap between the S's and the P. So could there be all S's overlapping with the P's? Absolutely not. Same thing over here. So if it's false that some S's are not P's, so for example, if it's false that some cats are not mammals, then it must be also false that no cats are mammals, right? Because if it's false that some cats are not mammals, then it must be true that all cats are mammals. And if it's true that all cats are mammals, then it must be false that no cats are mammals. Okay, so all of those different relationships are summed up in this relatively famous chart here. So it's got all 4 of the different categorical statements at each corner here, and little lines showing you the relationships between all of those different universal statements. In the book, they do this, and this is something that's done elsewhere. I didn't really make any kind of a big deal out of it here, but all 4 of the different universal statements are symbolized by a capital vowel letter here, just to draw your attention to that. If you see that in the textbook or elsewhere, that is the case. People like to do that. Okay. Here's another thing that it's good to be aware of these things, necessary truths and necessary falsehoods. So a necessary truth is a statement, once you've sort of filled in some content into the categorical statement, it's a categorical statement that just cannot be false. And the most straightforward example of this is when the subject and the predicate are the same term. Right? So all dogs are dogs. It's like there's just no way that that could be false. And then the flip side is a necessary falsehood. Right? So this is a statement that's impossible to be true. And so this is the negative universal statement when both terms, both the subject and the predicate are the same term. So no dogs are dogs. That can't possibly be true, right? So since all dogs are dogs, so it's got to be necessarily false that no dogs are dogs. And I bring this up partly because, like I said, it's sort of useful to be aware of the existence of necessary truths and the existence of necessary falsehoods, but also because if you're dealing with any of those logical relationships, right, contradictories or contraries or subcontraries or whatever, and then when you fill in content, at least one of the categorical statements that you're dealing with is a necessary truth or a necessary falsehood, then the standard relationship between those categorical statements might not hold up, right? Under normal circumstances, they might be subcontraries, for example, but if one of them is in one of these categories, then the subcontrary relationship might not hold up. Here's another concept to mention that is important to know about. So logical equivalence. This is when we have 2 statements that logically imply each other, that is. So they must always have the same truth value, right? If one of them is true, then the other one's got to be true. If one of them is false, then the other one's got to be false. So the no S's are P and the no P's are S's, that one's pretty obvious, right? I'm going to hit the Venn diagram here. So on the left, no S's are P. Well, let's say that's true. Okay, well then that's represented by this Venn diagram, right? No S's are overlapping with the P circle at all. Well, if that's true, then the reverse is true too, right? That the no P's are S's, right? If there's no overlap, then there's no overlap. Okay, then how about this one? If it's true that some S's are P, then it's also got to be true that some P's are S's. And this is one we've drawn attention to a few times now. Some S's are P, then that means that there's overlap between the S circle and the P circle. But if there's overlap between the S circle and the P circle, then it's also going to be true that some P's are S's. Okay, so that kind of sums up the basic sort of logical relationships between the different standard categorical statements. And then in the next chapter, we'll see how categorical statements are. In the next chapter, we'll see how the categorical statements are used in arguments. All right, I'm going to go ahead and stop there.